To do KE Jetronic System servicing, you must know KE Jetronic System servicing, because many procedures are the same for both systems. Brought to you by Bosch. In this program, you'll see service procedures that are different for KE. You'll know how to perform basic checks of the system and to do these procedures. KE Jetronic systems can be slightly different in different cars, and engines can be a lot different. So check the vehicle manual for specs and procedures. Meter readings shown in this program are typical, but do not apply to any specific engine. Don't forget to check ignition system, compression, and other engine conditions, such as vacuum leaks, which could be causing a complaint. When you're sure engine condition is okay, you can follow the underhood decal and the shop manual to run your basic checks of the KE Jetronic system. Get the whole picture before you start making any adjustments. On most KE cars, you'll find an idle speed stabilizer. Using an appropriate adapter, hook up the dwell meter to read normal dwell. Remember, ignition off before you make any hookups or go into the system, but the engine must be warm. Typical dwell at warm engine idle is about 30%. Be sure all electrical loads are off, including the engine cooling fan. Any load would change the dwell of the idle speed stabilizer. Now hook up the rest of your test equipment to check timing and idle RPM. The reason you didn't hook it up earlier is that some test equipment can change the idle stabilizer dwell readings. When you check timing and idle RPM against the engine specs, notice the computer can control the idle speed stabilizer to hold very small RPM tolerances. To check engine CO, look for an exhaust tap ahead of the converter. After you remove the plug, you can slip on the sampling hose, and be sure it's a tight fit. You'll need an appropriate adapter to connect your digital meter to the pressure actuator. You'll be reading milliamps of current controlling the mixture. Increase engine RPM to be sure the oxygen sensor is hot. If there's a heating circuit for the sensor, you don't have to. Make sure the sensor is connected for closed-loop operation. Be sure actuator current is in spec. Current must fluctuate, hunt back and forth a milliamp or two. That's a sure sign the system is operating closed-loop. The CO reading must also be in spec. If the engine has an altitude sensor, current will be reduced by about 1 milliamp for each 1,000 feet above sea level. If idle adjustments are necessary, start with mixture. If mixture is not in spec, the actual adjustment is the same as on KE Jetronic systems. You'll read CO, but in KE, you'll also read actuator current. You're looking for both to be in spec. Follow this closely. In some cars, you'll adjust mixture closed loop for the specified actuator current, which will be fluctuating, then check CO to be sure it's in spec. In other cars, you'll adjust mixture open loop for specified CO, then check closed loop to see that the actuator current is in spec. If you think about it, you'll see why that's two sides of the same coin. Closed loop, set actuator current, check CO. Open loop, set CO, check current. What if you can't get both actuator current and CO in spec? You can check for exhaust leaks, which could keep you from matching actuator current and CO. Applying air pressure to the exhaust gas tap may help you find them. Exhaust leaks must be eliminated because if leaking air reaches the oxygen sensor when the engine is running, it can fool the system into delivering a too rich mixture. You can adjust idle RPM with the idle screw when the engine has an auxiliary air valve. Adjust it the same as you do on a KE Jetronic system. But when the engine has an idle speed stabilizer, RPM is not adjustable. Instead, the idle idle RPM is programmed in the computer to control the idle stabilizer dwell. Remember, when you adjust the screw bypass, shown here on top, the control unit changes the dwell signal, which alters the stabilizer bypass to hold the RPM. So when do you adjust this screw? When stabilizer dwell is not in spec. Turning this screw, in effect, adjusts dwell, not RPM. Check it open loop or as specified. If you can't set dwell to spec, check the stabilizer according to the manual. If it's okay, replace the control unit. After these checks, if the engine still shows problems of starting or drivability, the KE Jetronic system may need further tests. But first, stop now for review of basic checks and idle settings. Checking the KE sensor plate and plunger is important to starting and to drivability because it affects fuel sealing in the lines. Remember, when the plate is in zero position, it rests on its spring with clearance between the roller and the plunger. It must have free travel, so you can move it before the roller touches the plunger. Here's how you can check that. After you've pulled the fuel pump relay, attach a fuse jumper with a switch so you can run the fuel pump from under the hood. You'll want fuel pressure to push the plunger down onto its O-ring seal for this test. In the zero position, the plate must be below the edge of the funnel so you can see all of the vertical face as shown here. If you have any doubt, check the specs. And using a depth gauge, measure to the zero position of the plate with your gauge closest to the fuel distributor. What if zero position was not in spec? After unbolting the mixture control unit, bend the wire clip to adjust the zero position. But don't bend the arm supporting the clip. And if you reach in from above the plate, don't nick it or scratch the airflow sensor. From the correct zero position, shown in the bottom picture, you must be able to lift the plate the specified distance to the basic position at the top edge to touch the plunger. That's okay. If plunger clearance is too small, the plunger cannot rest on the seal, so the system can lose line pressure. That's not okay. There's another problem. If you can lift the plate above the edge before you touch the plunger, so you see space around it like this, that means plunger clearance is too large, so the engine will be hard to start. That's the updraft story. Now, let's look at the downdraft, which is pretty much the same. Again, run the pump a few seconds for pressure on top of the plunger. Before you press the sensor plate, look at the zero position. It should be even with the top of the cylinder, near the edge of the upper funnel. Zero position looks okay. Notice the bolt does not touch the rubber bumper. Its upward movement is limited by a spring stop. If zero position were wrong, you'd adjust the guide pin for the spring stop. Too high means hard starting. So drive it down to lower the zero position. From proper zero position, press down to basic until you touch the plunger. The plate should be at the bottom of the vertical face, like this, so you can see all of the cylinder, but none of the funnel below. Basic position looks okay, but is it? To be sure, measure the travel from zero down to basic against the specs. Downdraft measurements are made in the center because of the angled plate. In this case, 4.2 to 4.4 millimeters travel is necessary to provide plunger clearance. If travel checks out okay and other specs are okay, no problem. But if you can push the plate below the edge before you feel the plunger touch, so you can see below the edge like this, that's not okay. You need further checks. So whether updraft or downdraft, remove the fuel distributor to check the plunger's seating on its seal. Check the distance from this surface to the roller on the sensor plate arm that lifts the plunger. If this checks out and the other specs are okay, reinstall the fuel distributor. But if you're still out of spec, or if you have problems of starting or drivability, you need to turn this nut so the plunger will seat on the O-ring. 1/4 turn here will usually change the plate travel clearance by 1.3 millimeters, but be sure to check your specs. You should not have to do this often, but when you do, it's one of the most important adjustments of the KE Jetronic system. You may stop now for a review of sensor plate and plunger. Before you run your pressure checks, remove the gas tank cap. Remember, these tanks normally are pressurized about 1 to 2 psi, enough to move fuel through open lines. When you open the lines, always relieve pressure first at the upper fitting and catch any fuel with a cloth. If you open the lower fitting first, you will not relieve all pressures. In this case, open the start valve fitting. In some cars, you'll find a special test connection. Connect the pressure gauge so the shutoff fitting is attached to the upper connection. That will measure system pressure. Connect the other fitting to the lower chamber test connection using new seal rings to contain the pressures. Check the manual for special fittings if necessary. Run the pump with the jumper. You'll see system pressure on the gauge, 5.5 bar in this case, with the valve open to the upper connection as shown in red. From the KE Jetronic system program, you know what to check if system pressure is not up to spec. If everything else checks out, replace the KE pressure regulator. It is not adjustable. When you close off system pressure with a valve, the gauge reads 5.1. That's warm lower chamber pressure, shown in purple, with 10 milliamps actuator current. Ignition should be on. The specs read pressure difference, 4/10 bar in this case, shown by the white arrow. 4/10 bar pressure drop means subtract the specified drop from your measured system pressure. Suppose the pressure drop is too small. Then you'll measure through flow from the lower chamber to be sure nothing is clogging that restrictor returning fuel. Check your specs. Through flow is about 1/10 of pump delivery, so you won't see a big stream, but this measurement really matters. Reconnect the hose to the lower chamber for the next pressure test. To check the cold differential pressure, plug a 15 k ohm resistor into the engine temperature connector. That sends a cold engine signal to the computer. With oxygen sensor disconnected and ignition on, check the cold pressure drop, 1 bar, indicated by the arrow, against the actuator current, about 60 milliamps. Cold lower chamber pressure, 4.5 bar, will usually be specified as a drop from system pressure, 1 bar less than 5.5. The leak test is the last pressure check. With the valve open, you have run the pump briefly and shut it off. 20 minutes later, you should read at least 2.6 bar residual pressure. If residual pressure is too low, check each point indicated by a circle where the system could leak off pressure. You may stop now for a review of pressure testing. To check idle stabilizer operation under several conditions, you need to reconnect the dwell meter. Pull the pump fuse so the engine won't start, and so the pump won't deliver fuel into the cylinders during cranking. Also, disconnect the engine temperature sensor to simulate engine cold. During cold cranking, the dwell, about 60% in this case, shows the idle speed stabilizer is delivering extra air to help the engine start. Reinstall the pump fuse and start the engine. Even engine cold, the idle speed stabilizer holds a steady RPM as specified, slightly higher than warm idle. So much for the cold engine test of idle dwell. For the off-idle test of dwell, bridge the engine temperature sensor leads as if the engine were warm. Now, raising RPM slightly to open the throttle switch, read the dwell, in this case 32%. You should see an increase from the normal warm engine idle dwell of 28%. In most cars, when you turn on the air conditioner, the idle speed stabilizer should increase RPM slightly above warm idle. That spins the compressor faster for better cooling. On the other hand, the idle stabilizer should hold the same idle RPM even when you turn on the lights or add other loads. Dwell increases to carry the extra alternator load. You may stop now to review the idle speed stabilizer. Finally, a series of checks for control operations. Simple tests you can run to satisfy yourself these are working. You won't find all these control functions on all cars, so again, check your specs. For the post-start and warm-up check, again pull the pump fuse to keep the engine from starting and remove the engine temperature sensor connector, signaling that the engine is cold. When you crank it briefly, you'll see post-start enrichment, 140 milliamps in this case. Leave the ignition on. For about 30 seconds, post-start enrichment continues, then slowly reduces to warm-up enrichment, in this case about 80 milliamps. Check the specs for your car. For cold acceleration enrichment, quickly lift the sensor plate while holding the throttle to open the idle switch. You'll see max enrichment, over 140 milliamps in this case, for about 1 second. Then, it'll drop off quickly to warm-up enrichment. Remember not to do this if you have fuel pressure, because delivery will flood the cylinders. For the full load check, bridge the engine temperature sensor lead as in a warm engine. With the engine running about 4,000, note the actuator current, then close the full load switch. Look for 3 milliamp increase to 12 with switch closed. That's an increase from 9 with switch open. Briefly run wide open to check RPM limitation. Look for minus current to the pressure actuator. Snap the throttle closed and look quickly for negative current. It's the same action as RPM limitation, closing off the fuel, but of course you'll see positive current as soon as the RPM approaches idle. To check control unit operations for the oxygen sensor circuits, go open loop by disconnecting the sensor. With ignition on, engine warm, look for a steady actuator current, 10 milliamps in this case. It will be less if you have an altitude sensor and if you're above 2,000 feet altitude. If so, disconnect the altitude sensor. Ground the oxygen sensor terminal leading to the control unit as if the mixture were too lean. Look for 20 milliamps, a 10 milliamp increase, as the control unit drives the system to the rich stop. You'll see the current increase in about 20 seconds. When you remove the ground, wait about 10 seconds for the system to stabilize. Then apply about 1 volt to the terminal, as if the oxygen sensor were sending a rich signal to the control unit. Look for the actuator current to fall toward 0 as the system is driven to the lean stop. You have checked control operation and the oxygen sensor circuit. In this program, you have seen how to do the basic checks of KE Jetronic systems. You've checked CO against actuator current, which must fluctuate in closed loop. You've checked idle stabilizer dwell and idle timing and RPM. You've seen how to make idle adjustments, idle stabilizer dwell for programmed RPM, also how to set mixture, matching actuator current with CO. How to check sensor plate clearance, the lift of the plate from 0 to basic, and what you must do if there's not enough clearance or if the plate can be lifted too far. How to do pressure checks, measuring system pressure and checking pressure drop in the lower chamber for various conditions. Also, how to check through flow and residual pressure during the leak test. How to check changing idle stabilizer dwell under various conditions and its ability to hold RPM during changing loads. You've also seen how to check control operation, measuring actuator current for different operating conditions of KE Jetronic systems. Brought to you by Bosch.